Hey everybody, this is Larry, this is me with Q4 of the weekly contest 466, right? Count binary palindromic numbers. Hit the like button to subscribe and join me on Discord. Let me know what you think about this one. You're going to see like a lot of different solutions and implementation of this problem. I think honestly a lot of these problems have the same idea, maybe implementation's a little bit different. Sometimes you can kind of make certain things a little bit straightforward and easier, and you'll see different implementations. But I think the core idea is about the same, and we'll go over it. And the first thing for me to say is that n is 10 to the 15, which for a binary number means it's about 2 to the 50 or something like that, right? So we have effectively, quote unquote, n is equal to 50, n being the input size. So we definitely not worry about time if we're able to do binary in a good way, as long as we, do it in a, like I said, do it in a good way, right? The other thing to note is that as a result, honestly, I immediately jumped to this thing called digit DP. And I actually ended up having two wrong answers on this anyway, but one of them was just a typo. You could watch the live portion, it was just dumb. I kind of muck something around. But another thing that you can do for these counting problems, and I call it counting problems because, well, you're just counting some stuff, right? Is that you are able to, or you should think about implementing a quote unquote dumb, naive solution that will time out for small n's so that you can use it as a reference. Especially if you don't feel super confident about it, and I didn't. I ended up taking about an hour and 8 minutes, but also, I think I have most of the ideas in very quickly, maybe 20 minutes, but then it took me like an extra, well, the rest of the time, because I was missing one edge case, which we'll talk about, but I already spoiled it a little bit. It is digit dynamic programming, and what is that? Well, we will go over. I will also warn you that I do write my digit dynamic programming a little bit differently than other people, because I think a lot of people just use a template, which honestly, maybe if I had a template, it would be faster to write. But for this one, I don't think speed was the issue. I was just missing one case that I couldn't think through it. And you can watch the live portion and see how I debug it. But yeah, okay. So what was the core? At the core part of digit DP, it is just enumeration, right? And by enumeration, I guess maybe for counting numbers is not a great way to say it, but I mean by case analysis, making sure you have every case. And for this, I will bring up the drawing board. Okay. So the core idea behind this is, we have a palindrome, right? Well, what's a palindrome? It is this plugged in? My drawing board is a little bit awkward, so. All right, well, I have to debug this later, so I don't know. Okay, so we will not be drawing. But the idea with palindrome, and this one maybe I don't need the drawing that much anyway, is a sort of case analysis, right? So what is a palindrome? A palindrome, it is something that has the first character is equal to the last character, and then so forth in. And as we said, we have 2 to the 50, right? So that means that we only have a freedom, if you will, to change 2 to the 25 or something like that. Maybe not 2 to the 25, but just 25 digits, right? Or 2 to the 25. So that's still too big, obviously, for us to kind of do anything crazy with that, but that is the idea. Because you only get half the digit, the other half you're forced by the first half in a way, right? Like if you choose one of the ones to be 1, then 1, right? Okay. The second part is, and the way that I always structure it is a little bit different, as I said, to the other people doing it, but I think it's fine. Maybe it's a little bit slower though, to be honest, if you want to like optimize for high level competitive programming. But for me, honestly, I don't care that much. It works for me, so it's fine. I'm also not pushing my rating limit or anything like that, so you can take it as you will. But anyway, but for let's just say, you know, we have so we have some number, let's say 10 to the 14, right? So that's like 1, that's a lot of zeros, whatever it is, just some big number. And then we first convert this, actually, let's make this a random big number. I'm just banging on the keyboard. Maybe that's too many banging. But okay, so we convert this to a binary number. Also, this is a random number. I don't think this is the actual what it converts to, right? Right? And then the idea is that, okay, well, then this number has a length. And I don't know what this is, right? And we'll just make it up, right? So let's just say size is equal to, I don't know, 30, right? Well, what does that mean? We could probably count it, whatever. Let's just say size is equal to 30, because it doesn't really matter. That's not the point. If size equals to 30, that means that, well, it means that every binary palindrome under the size of 30 is good, right? What I mean by that? That means you can have size 1, well, and also maybe size 0, depending on how you write your sizes. So size 0, and then you have like size 1, which is right, and these, oh, well, that's not a palindrome. You have 0, 0, which is not a palindrome. So, you know, you have for size 2, you only have 1 as well, right? Because yeah, you brute force, and we'll go over this more in detail later, right? But the point is that, yeah, in size 3. But the point, and then here we dot, right? But the point isn't that, you know, how we generate these. We'll go over how we generate these in a second, but it just means that every binary palindrome under 30 is good. We don't have to worry about any conditions or anything like that. We just blanket say that it is good, right? Size 0, this one you can say is 0 and 1, depends on how you set up your base case, to be honest, these things. Yeah, and how you add them up. Right, so everything. So then the only question is, well, what happens if you have the full length here, right? So full length, we cannot take every palindrome of this length, and that's basically, and that's the. So now we separate into two parts: the quote unquote complete parts, and then the incomplete parts, right? First of all, let's go about this part and go over how to solve it. Well, the idea here is just becomes a combinatorial problem. 0, 1, and even 2 maybe we'll just skip it as base case. You can see why. I mean, you know. But then after that, what happens, right? So now to generalize, let's say you have size x, then what happens? Well, let's just say for first of all, let's say x is equal to even, right? Then let's put it back here. Let's say x is equal to even. Then what happens when x is equal to even? Then you have x over 2 digits. That can be anything, right? The first x over 2 digits could be anything, and then the second digit has to be, you know, the mirror of it, right? Palindrome. So as a result, they can be anything. That's just 2 to the power. Oh, sorry, I'm wrong on this one. I think I made the same mistake during the contest. X to almost, right? And what I mean by that is, I mean that the first digit has to be of 1, because you cannot have a leading 0 of x digits. So you have leading 0 of 1, leading digit of 1, and then you have still the same thing, mirror, right? But and I think I drew them a little bit different size, but you get the idea, right? You have the left side, you have the right side. The first digit has to be a 1, so the last digit has 1. So that means that it is actually x minus 2 over 2 digits can be anything, right? And then in the same way, if x is equal to odd, then we have 1 and then some number in the middle, right? I just call it I don't know, O for anything. Well, I guess it's just another blank, maybe. I don't know. Notations are hard, right? So then this, of course, here the x minus I mean, you have to round down and stuff like that. So you could do the math really precisely, which is maybe x minus 3 divided by 2 digits, right? Because you subtract 1, you subtract 2, subtract 3. So there's x minus 3 digits in the middle. And then times 2 for the middle digit, right? And this part hopefully should be pretty, yeah. This part, hopefully you're able to reason it out. It is just basic combinatorics, right? Yeah. And then now, we have to do the hard part of the digit DP. And then now we have to do full length. And this becomes a case of, like I said, case analysis. And you just have to be really careful. And I honestly, during the contest, I did not. Or I was careful, but I was just missing something, right? Like I YOLO'd because it kind of passed. And I thought the first time I submitted, I had a typo. Or maybe the second time, I forget. But after that, I YOLO submit everything. I test cases, compared them to my brute force, it was right, but there was an edge case that I forgot. But we'll go over the things real quick. Let's just say for the purpose of this problem, or for now, we'll say size is equal to even, right? Just to keep it simple. Like we said, I mean, it's the same idea with this, but we'll start with size is equal to even. And what happens? And of course, the first one has to be a 1. Same thing, right? Then we have to throw the rest, right? So then now we have this case. Let's just say we have here, the first number has to be a 1, and then what happens? And then we just kind of, this is a prefix sum type thing, right? So if, sorry, not prefix sum, but digit DP. So it has very standard digit DP things, to be honest. And what I mean by that is that, okay, the only two, so we know that this is a 1, so that means that the second digit will have to, if this is a 0, then it has to be a 0, right? There's no question about it, because if this is a 1, then this would already, whatever the rest of the number is, whatever number this is, it would already be bigger than that number, so it's just not good, right? So this has to be a 0. Okay, so the next number, this is a 1, so then now it could be either 0 or a 1, right? So this makes it a lot of freedom, but there's some the states are a little bit different, right? Because if this is a 0, that means that the rest of the digits can be anything we want it to be. I mean, of course, there is some things about the mirror for the palindrome which have to go over, but that's the basic idea, right? If this is 0, then the rest can be whatever they want. And of course, you'll probably see this in other people's code if you just read it. Then this is also, as you can guess, like 2 to the x or whatever, right? Not this x, but 2 to the whatever, let's just say 2 to the L, which is the remaining part of this, because they can be any number, the L remaining digits, say, then it's just 2 to the L, right? Okay. And then otherwise, of course, if you have a 1, then you have to keep track of this prefix, and then the rest have to keep track as well, right? So then here, if this is 0, then this can be anything we want, as we said, right? Actually, even the rest. But if this is a 1, then this has to be a 0. Let's just do like multiple ones in a row just to mix it up a little bit. Same thing here, right? If you have a 0, then anything can be. If this is a 1, 1, and then so forth, right? And that's basically the states, right? Because half of them you can do whatever you want, and the other half you have to kind of follow the prefix one by one. Okay, so this is how you would do a normal, quote unquote, a normal digit dynamic programming. We haven't talked about the palindrome much yet, and this is the part that makes this part different from other digit DP. So a lot of people seem to have gotten it, so it is different, and for me a little bit difficult. And I found it like challenging in a good way, to be frank. Like I appreciated it. But yeah, so then now there is actually one more weird case, right? Because let's say you have let's do a smaller number now, right? I think I just wanted to get a long number for visualization for here, but for let's get a smaller number to kind of play around with this a little bit, right? So let's say you have I don't know, something like this, right? Yeah. Okay. So then, as we said, our first digit has to be let's actually mix it up a little bit. That first digit has to be a 1, right? So we already know that as palindrome, then it will look like this, right? Every possible good number has to look like this. And then now we just kind of recurse on it, right? Well, what if and as we said, if this is 0, I mean the prefix is a 1, so if this is a 0, the rest can be whatever they want, right? I mean, of course, we have to mirror it, so there are only 2 other 3 digits and not 4, just to be clear, but you get the idea hopefully by now. But what if we have a 1? Well, then if we have a 1, then we have to fill it out, and then we have 1 on this side. But wait, this is the tricky part. This is the part that, well, just sets this problem apart for a little bit, which is that if this is the case, well, we compare it to the original number, right? All right, let's put it here, right? The thing is that now, if we put a 1 here, that means that we have to put a 1 here, because that's how palindromes work. And as a result, this has a possibility of greater than 0, and you have to figure out how to resolve it. That is the key part about this. And the solution turns out is that, well, anything in between has to be, let me give you not the incorrect, but the imprecise version that I did during the contest, and then we'll talk about an edge case. During the contest at this time, I thought, oh, okay, and honestly, I failed myself a little bit and slowed myself down. If I drew myself out, like drew these visualization out, like I showed you here in my notebook, but I tried to put everything in my head, so it took me a little bit longer than I could have or should have or whatever. Definitely recommend writing it out. But but when you write it out like this, it is obvious, right? Which is that when you have a 1 here and you have a 1 here, that means that we have to have a 1 in the middle, right? Because I mean, maybe, and this is like half. So, but yeah, for example, if we have a 1 here, if we have a 1 here, it doesn't have to be the next one. It could be anywhere in the next place. Then that means that, well, as we said before, if well, this one's not possible like this, sorry. So maybe we have a 1 here, right? So we can actually choose a 1. But if we have a 1 here, I mean, because this 0 has prefix 0, so we have to choose a 0. But if this is a 1, and we picked a 1, did I mess up my explanation? I mean, I think this is right? Well, kind of. No, all right, let's just do it the other way. I think this is, I mean, I think the thing is right, but the example is wrong. But yeah, so you have something like this. As I said, this could be a 0, and obviously the rest can be anything. So anything means that even this 1 is possible because it's always more than 1. But if you have a, oh, I see. Yeah, I messed up. This is a bad example. So let's just say we have this for now, right? Yeah, if we have a 0 here, that means the rest, you can be anything, and this will always be smaller than this number, so we're good. But the other case is that, okay, well, if you have something like this can be a 1, right? And if you have a 1 here, what does that mean? That means that you have to have a 1 here. And note that in this case, man, what is the example that I'm trying to do? I am messing up a little bit. Sorry, friends. I am confusing myself a little bit. But the idea here is that we need a 1 here so that maybe that's where I got things wrong. Maybe I'm confused. Sorry, friends. Give me a second to regroup. But yeah, but the idea here is that, okay, well, now that you have a 1 in some, No, I think it's the other way around. I mean, I'm missing. So if you have a 0, then now it resets the need, and then you and this is always going to be smaller. But if you also have a 1, for example, yeah, let's say this is a 0, and then now you have a 1, right? Huh. Man, I am confusing my edge cases. This one is very tough. Maybe I shouldn't have taken a nap. Huh. This case, I knew about that case. No, I think I just confused her. I see, I see. I think the case here. Man, how did I even get this right? Tells you how hard these are sometimes that I don't even remember how my logic worked from yesterday or this morning. But yeah, but that's kind of the core part of the idea, is trying to squeeze these numbers in a way. And maybe my case analysis is really bad on the explanation, my apology. And we'll go over the actual code and they'll be more clear. But the idea here is that, yeah, as a result, you construct the prefix in a way such that even though this 1 is bigger than here, we know that there is going to be a case in which there's a 1 here and there's a 0 here, and as a result, when that happens in the in between cases, right? When you have I guess this either here or I guess even here or something like that, because okay, I think that's where I confuse. I think I confuse the 0 and the 1 in my comment, because if I have the prefix, I have 0. This is still no bueno, right? Because that it still means that this 1 can still be make the number here bigger than this number. But as soon as we get a 0, then now, but this 0 means that this number will always be smaller than this number, and we are good, right? Of course, you can also have this number 0, and this number 0 means that you will have to throw out this 0 here, and as a result, this number will always be smaller than this number. So it's just a lot of case analysis like that. And then there's one more case that I even leave a comment here, is something like this, right? Yeah, the idea here is that if you put a 1 here, that means that you have to put a 1 at the end. And then now if you put a 1 here, this also has to be a 1. So then if you now put a 0 here, there's a 0, and as a result, this number will always be smaller than this number, assuming that all the prefixes met, right? So it can be turned on again and stuff like that. But that's the general play of the idea. The idea here, I mean, maybe I could have gone over the cases more in detail and kind of walk you through all of them. But that actually, honestly, that is the problem. That is the tricky part about this. It's just all these kind of interactions between the 1s and 0s. But of course, because there are only 2 numbers, 0 and 1, makes it at least easier to enumerate. So we'll go over the code now, the way that I kind of went over it, right? And the way that I write this is top down, but as you can see, there are a lot of cases where, like, if this is, maybe not this one, but if this is 0, the rest is, 2 to the L or whatever. So there's a lot of, like, 2 to the power of 2 type things. So if you read other people's code, that's how you see it. And I have a little bit, but I wrote it differently, right? Okay. So, yeah, the first thing I do is I write something called G. I don't know. I think with these functions, I always just write them as F and G. I don't know if it makes sense. But G basically gets, well, just the answer, right, in this case. The reason why I kind of write it this way is that it's a little bit of an abstraction. For this particular problem, we're going from 0 to n, right? Inclusive, right? Every number less than n. But very often they ask you from like, I don't know, A to B or something, right? And so you're getting like a chunk, which actually I'm surprised they didn't do it for this one. It's trivial to change. But then now you just do the prefix sum logic of, okay, to get from A to B, like the chunk in the middle, it is just from 0 to B minus from 0 to A minus 1. And so if you have something like this, then it's a little bit easier. And to get the answer, we already said, which is that sum up every size smaller than the size, right? So we just have this, and we have this function. I go A for all, and this actually doesn't change for all the problems. I can just do it this way, but also it's like pretty straightforward, right? X is only up to 50 or whatever, so this is pretty cheap. And this is, we already talked about this, so this one is fine. Also, I have small numbers that I pre-calculated, so I can return them. Honestly, I just do so that I don't have to handle like 0, 1, 2 digits, because then I don't know, just don't have to handle it in case, like, you know, they're just like weird interactions sometimes with small base cases. So I was just like, all right, well, let's just cache them and then pre-calculate them. Otherwise, then now the second part is to have this recursive function. Yeah, I think I labeled this wrong. Maybe I was just thinking about it incorrect yesterday, and then I got it confused. Need to be smaller in the future. So I have this function, right? We have index, which is what index are we looking at? And I skipped a little bit, sorry. Which is that I convert it to a binary string, right? The number to a binary string. I get the size, and m is the middle, so it's just, you know, round up, the digit middle round up, so it works for odd and even as well. Okay, so this function, what index we're looking at, keeping in mind that we only go up to m, which is half because this is a palindrome. We have the prefix, whether it matches the prefix. If it matches the prefix, then we do this thing that we have to walk the one digit at a time. If it doesn't, then we just do the 2 to the L thing. Actually, don't do explicitly 2 to the L, but as you see, it actually does the 2 to the L thing for us. And then need is that, like, we match the prefix and need to be smaller in the future so that the rest can be true, kind of, right? And this is kind of what we said. If we have something like this, you need a 0 where this is a 1 in the future so that it just stays smaller, right? Because in this case, well, there are other conditions, of course, but for example, because this one cannot be a 1 because it's constrained here, but assuming all the other the rest of the things are filled, this should be good. And that's basically what this does, right? Yeah, and then we'll go with this function, and it's like I said, a little bit of case analysis, a little bit tricky, but yeah. So if it's m, meaning that we reach the middle, if we match the prefix and we still need to be small in this future, then we just return 0, right? Because yeah, we match everything in the beginning, and so the rest have to match. But because we cannot get smaller, we return 0. Otherwise, you have 1 for just one. It's just a typical base case. Otherwise, this is total, right? So need is the new need. I don't know, new need. And this is just to, actually this is part of this, just to be clear. So we try a 0, right? So new need is if we have a 0, I mean, the way that I wrote this is a little bit weird. That's why I'm pausing. Hang on, sorry. I think like you could write this as like, you could write this as a one-liner for sure. But this is basically if we have a 0 where Well, yeah, I see. I think it's implicit because I think you suppose what I supposed to or should do. This should be s of index is equal to 1 or this, right? I think that's a little bit more precise, but the reason why you don't need, I didn't need it, and I didn't make it explicit, is because when this is the case, when s of index is equal to 1, then the prefix part automatically goes to false, and when the prefix part goes to false, you do the 2 to the L thing. We'll trace through it, but it does 2 to the L thing, and as a result, we don't look at need again, which is maybe a little bit hacky, but to be more precise, this is the case, right? Which is that if we have a 0 and we have a 1 in either this current index or the mirror or the palindrome, I just call it the mirror, right? The mirror index, then this number will always be smaller. So set need to false, right? This is a very long line. So set need to false, and that's basically what we did. Again, I guess I didn't have this here because, this, right? You can also just say that this is always false when this is the case. So maybe you could write like, this, like you write something like that. If that's, I don't know if that's cleaner. Is it cleaner? Let me know in the comments. But yeah. And of course, you could do the one-liner of if either of this is true. I'm not gonna do it. I feel like I'm gonna mess up and confuse people who just look at the code and don't listen to it. But yeah, but that's basically the idea, right? Yeah. Otherwise, and this is just trying a 0, right? If it's a 0, then the prefix either continues. If the index is 0, then the prefix continues, and when the prefix continues, the need is going to keep going, right? Whether we still need another way to in the future to get smaller. Otherwise, we try a 1, right? Well, I guess this should be a return, but I don't know. Anyway, good is whether we can be good, right? So if we want to try a 1, if the s of index is equal to 0, then, well, we cannot try a 1. So we said good is equal to false. Maybe we can do an early return, but it felt a little awkward when I was writing it. Anyway, otherwise, then we need the prefix is equal to true. So this is actually always true. I actually even rewrote this as true. I guess I took it out and forgot about it. Let me just make sure that it works before I, yep, accepted. Okay, fine. Wait, was it accepted or was it attempted to? Okay, fine. Leetcode UIs or whatever, right? Good is equal to false, right? Otherwise, I guess we keep going anyway, but if it's not good, then we just don't add, right? If we try one, and this is with the prefix is going on, right? Because if the prefix is not necessary, then we just keep going. And also, yeah, we'll talk about this later. But yeah, if the mirror is a 0, then that means that we need this to be true, right? Otherwise, we just keep on going the need because you have a 1 and you have 1 in both those things, so it doesn't change the state, and you just kind of keep going on the need side. Again, maybe you can write this similar to here for the need, but I'm just going to leave this here for now. Okay, and if the prefix is not true, meaning that this is the 2 to the L route that we were talking about, where you could put in anything, then we just kind of do this, and that's it. We return total. This is I know that maybe I didn't go over it super well, but like I said, this is case analysis, so definitely challenge yourself at home if you're struggling a little bit, and just draw out what I mean, like in this case, and then kind of go over it. It took me a while. I don't know. But yeah, so how do you get 2 to the L from this? Well, if prefix is false, then we always, if prefix is false, I think it does either one of these two, but it doesn't really matter because it always does it. And if prefix is false, then this always happens. And because both of those cases, prefix remains false, so then you just keep going, right? You keep branching 2 in both cases, and then it just becomes 2 to the L. And that's basically it. Yeah. So what's the complexity here, right? This one, as you can see, I mean, it's just regular PAL. So it's for 50 digits, you could say this is linear for PAL. I mean, maybe not, because some stuff is always awkward when you come to things. But when n is 50, this is relatively small. And as you can see, index is only up to 50 or even 25 really. But say O of 50, prefix is true false, need is true false. So this is going to be O of 25 or O of 50 or O of n, where n is the size of the binary number. And yeah, and that's it. So basically the idea is just try 0, try 1, but the key thing to note is, I mean, prefix, straightforward with respect to a digit DP. So I mean, you should probably do easier digit DP if you're struggling with digit DP. I mean, why work on a harder problem first, right? But then the key thing to know is this, we match the prefix and need to be small in the future so that the rest could be true, right? We kind of did some visualization here where, one of these things, and it doesn't have to be this one, right? I mean, on this side, it's a little bit more straightforward because then now you just set the prefix is going to false, and then everything's going to be counted anyway. But if you have, the key thing is the thing about the mirror. If the mirror is 0 and the mirror requirement is a 1, then it's always going to be smaller, and that's the thing that I missed for a long time. And that's it. That's all I have with this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in contest next. I do, for this one I recommend watching it a little bit, maybe on fast speed, because I go over how debugging, brute force writing, a couple of brute force to verify. I still got a wrong answer for a silly reason. Well, one is a silly reason because I just had this number bigger than this number, so I had this number bigger than this number, so like I was just like going out of bounds or something silly, or just it didn't go out of bounds, but it just returned the entire array, which was too small. Very dumb. So that was one wrong answer. The second one was, I wouldn't say it's a silly error, it's just that I got it wrong, right? Like you're wrong sometimes, and I was just like off by 1 in a place, even though I checked it with the brute force, but there was just like off by 1 in one of the numbers in the middle and not on the numbers that I tested. So that's maybe a little bit unlucky because I tested like 5 or 6 numbers or something like that. But yeah, that's all I have. Thanks for watching. Let me know what you think, and you can watch me solve it live in the contest now. Okay, because that logic honestly is a little bit shaky, that logic, but worked well enough. 10 minutes, not that bad along. 1300 ranking though. Well, we could get this one maybe. So let's take a look. I actually didn't even look at the rankings. I just kind of saw my time. Okay, non-negative number n, binary palindromic, which binary reads the same way back and forth. Return the number of. Okay. N and the binary up k such that, okay, so and n can be pretty big, even 10 to the 15, so it's just 0 to 9. All right, let's think about this. All right, I guess it cannot be even because there's no leading 0. So but I just want to take a look real quick. Because this is 9, 10 obviously no good, 11 no good. Okay, so then we can do maybe like I'm just trying to establish some pattern, to be honest, just to kind of get me started really, but because I mean they'll be the same anyway. And 15 makes sense. Then we can construct this, right? Oh, what count 0? Actually, okay. I mean, we do count 0 in this case, but okay. So I mean, it's just taking the first half. and then seeing whether they all fit. That could be pretty big though, because 10 to the 15, so that's what 50 bits. 50 bits is a lot. Well, even 25 bits for half of it is a lot, right? So we have to be a little bit smaller than that. It's probably just digit DP, isn't it? Yeah, it's probably digit DP. How do I do a digit DP? Right, and there's no, I'm surprised they didn't do a range one, which is like left and right. It's just n is 0 to 9. It saves me like, I don't know, 20 seconds or something. Okay, so it's probably digit DP because it's 50 elements. That's fine, right? Yeah, okay. I mean, I'm so every time I do digit DP, I feel like I'm rusty, but I think that's probably it. Okay, so I always just put them up, right? Okay, so actually we want bin of n. Let's say string, right? And then now we want to say yeah, nothing crazy, right? Running with s, so size is equal to this, and then this is, I usually just do it by case analysis actually. So then this is just all numbers with smaller than Sn is good. So let's just sum it up. Total 0, 0. Is there no mod? I guess not. I guess this fits in long because well, that's upper bound. Okay, right? So yeah. So for I in range of SC doesn't include SC. Let's just say well, I. Okay. So then this is just cache it, right? Or palindromic or whatever, right? Okay. So then how does that work? With x digits, right? So if x, let's just say with 0 to 0, we just return 1 for 0. If x oh, it's binary. I forgot it's binary actually. I was like, something feels a little bit weird, but okay. If x is equal to 1, that's 1 digit, right? If x mod 2 is equal to 1, so if it's odd, I guess then in this. Is 0 1 digit? Maybe it is. And we just don't count the 0 digit. I don't know. I don't know which one is better, honestly. I mean, this should not happen. I don't know. Honestly, I think that may screw me up later, but we'll just keep this for now. Maybe add it to do. Okay, so then if it's odd, let's just do it even, right? If it's even, then what? You have x digits, then it's x over 2, so then it's just return power of 2 x over 2, right? Pretty straightforward. If else, then is power of 2 x right? Times 2, yeah, right? Pretty straightforward actually, except for maybe 0 case. So I'm thinking about the other recursion for now, so that's why. Okay, and in fact, though, this gonna be cached on all the problems, so we'll just put it here, right? Okay, and then now this is the okay, so then now I know some people have template for this, and honestly I'm not that good on this one. Okay, so we have an F that does, what do we want? We have an S, let's not put it in there. We have an index, we have whether it satisfies the prefix, or we're on the prefix check. I don't know how to do half of it though, or you have to do like both halves, and I think that's the part that I have to think about. Is that sufficient? I don't know. Okay, so then now oh, and whether we have a leading zero, so we should be fine. We'll just have to do we have to start at 1. The first digit is always 1. Prefix is going to be true for now because the first digit is always 1. But I still don't know how to do the suffix though. Maybe I have to think about this a little bit on the prefix, on the digit DP. Did I do the digit DP backwards? Would that help? I don't think so. I don't know how to do it forward. And you can put the 25 things on the space, right? I actually don't know. How do I keep the constraint on the prefix and the suffix at the same time? Okay, so maybe it depends on the input. If it's 0, then it doesn't matter. So given a, so if it's a 1 and you go over, we have to do the the previous. I think I need to draw this out honestly, but I'll try to do my best here. But if someone like this, right? So that's a palindrome as an input side, but then now you have this. That doesn't matter because this has to be 0. That's fine. But what if you have this? Oh. Can you have a 1 here? Does it depend on the other stuff? Let's say you have 1, 1 here. Can this be a 1? Yes, right? Because then that means that you have 0, 0. 1 is fine, right? So then now it becomes a case analysis, I suppose. How much time do I have left? An hour? Well, people got it really fast, so maybe I'm just doing it in a silly way. Like I think I could case it out, but it's definitely not a easy one, right? Because if you're basically saying if the rest of the thing has a 1 and we have to set it, because if it's all zeros until this one, then it doesn't work, right? So we have to basically have a 1. like required or something, maybe like a need. And this technically is true. Well, you only need a 1. Yes, because if it's always zeros, then you don't get it. You only need a 1 if the last digit is a 1 in this case, right? I don't even know. I'm just going to write something real quick, because I don't want to deal with edge cases. So then now is a if n is less than 100. Yeah. Does it go to 100? Okay, I just say 105 then. Did I delete that code? I guess I did. Okay, so it works for. Okay, I guess it has to do some other stuff first. Is that right? Yes. Oh, we got it. Whoa. Do we not have 0? What? How do I now have to debug this? Why? X in small, x is less than equal to n. No, that's right. Wait, I output 1, so why did I just look at it wrong? Oh, I looked at the input and I thought that would, okay, so this is why output, this is right, okay, fine. Okay. Because then now I can do things with double digits, but this is if s of n minus 1 is equal to 1, then you need 1, right? Okay. A prefix. I guess it always matches the prefix, because otherwise then you just go whatever you want, right? So maybe the prefix is always going to be true. I'll keep it in here for now, but I think I don't need it. The way that I wrote it out into a different function here. But okay, need a coming 1 to make the future true or something, whatever. Okay. Okay, so I is equal to n mod 2 equals to 1, right? So, okay. So let's say m is equal to n plus 1 over 2. So if it's 3, it will give me 2. Okay, that's right. 0, 1, 2. No, if it's 3, it's 0, 1, 2, and it'll be 1. Will be the, no, then after we want it to parse 1. Right? Yeah. We want it to, so we want 2. Yeah, no, this is right. Okay. And actually, I don't even think we need the odd part. It's just because you just flip it and it doesn't matter. Maybe. Okay. So then, okay. So if need, then we return 0. Otherwise, we return 1. I think. Otherwise, okay, try a 0, right? So if s of index is equal to 0, or is equal to, I guess we can always try 0, but it's whether, we can always try 0 for sure, right? But what does that mean? Index plus 1, okay, prefix. Yeah, I guess this part has to be whether s of index is equal to 0. And then you pass along the need, I think. But you have to also do that. No, I mean, I guess you don't have to do the other side, right? Because you always satisfy both sides, really. It's just whether it is the prefix or not. But then what are we tracking with prefix then? Oh, we're tracking whether, okay. Because the prefix is false, then we can just use the other function, right? If not prefix, then we can return. Oh, but the need part makes it maybe prefix is needed. I don't think so, honestly, still maybe, but we'll keep it here for now. I think it's okay to not simplify yet. Okay, so if s index, okay. Now then, this is actually not necessarily right. It's going to be prefix and this, right? Because then it just keeps going. So if it's prefix, then you keep going. Otherwise, try 1. Okay, so if prefix, then if s of index is equal to 0, then we can't. If s of index is n minus index, minus 1. If this is 0, then what happens? And this is the thing where we need, right? We need a thing in the future, right? So new need is equal to true. Yeah. Okay. I mean, it actually satisfies the previous need, but so it's something like, okay. So okay, so if it's 0, then new need is equal to true. Right. Otherwise, then now we can say f index plus 1. The prefix, we still have a, well, if it's 0, then we just can't. If this is true, we just do true. Now this pass is wrong. So maybe okay, and then now if this is an else, okay, so if it is a 1, then new prefix is just true. Maybe. If it's a 1, then we just don't care, right? Because we're putting a 1 anyway on the other side. Okay, so then now if it's good, go to the next number, new prefix. Yeah, we don't care about this. So decided just, I guess this has to be one or the other, but I think the way I wrote is fine. And then new need, right? Because it actually flips off the other one. But then now we need a new one if that's the case. Otherwise it's false. Okay. So if it's not prefix, what happens? If it's not prefix, then we could do whatever we want, really. Right? Then we do total f of index plus 1. It will never be prefix again. Need is always going to be false because we satisfied the previous needs. And then we are good, hopefully. The problem is that, like, these problems, I wish they give like just one big case, right? Okay, that's at least good in a way. What I actually want to write is also perforce, right? Then now I can write I said right, I think actually. List had, oh yeah, right. New. Oh, not S, but N. Okay, this line is off. Oh, it's not N minus 1. Oh, it is N minus 1 though, but huh? Why is N minus 1 would return, will be out of bounds? Oh, it's the size. Whoops, I forgot that size is, okay, fine. Easy fixed. And that's the same thing here. String out of bounds. Okay, why? Do I not have a base case? Try 0. We have a base case. Is that not right? Index. I mean, M is strictly less than N, so that should always just be right. Oh, it's, I keep on doing this everywhere. Okay. Okay, so the actual answer is 62. We have 105. That's no bueno. Let's try 100 actually. Okay. Let's just try with these 3 numbers. No, I guess 100. We hard coded it. Let's just do 500. I mean, we're still very wrong though. Ow, hurt my knee. I'm old. Just sitting incorrectly. Okay. How much time we have? 15 minutes. Hopefully that should be enough. So we're over counting, right? Okay, so we're over counting. So something is off with this. Let's turn this. This is if I need a number. Yep. This is where the prefix is true. It's always going to be true of the first digit. Or after the first digit, right? So this is over counting. Why am I over counting? It is hard to debug. New need, if doing 0, then, and we want to put a 1, then we need it. Yeah. I mean, try a 0, we try a 1, so we don't really do anything too funky. Hopefully, the prefix is false. That's true. This is true. Okay. If I mean, I thought I would be undercounting, honestly, but this is false, then we just do, it doesn't matter if we try one. If this is false, then we just keep going, right? So that means that we do both if the prefix is false. So this should be right. The prefix is false. It is 2 to the remainder bits. Did I do the thing wrong? Maybe this is, we have 3, we go to 2. Try this real quick. I mean, it's closer, but it's still off by a lot, actually. So I don't think that's quite. So it's probably this part. I mean, this card cannot be wrong, right? We could just even print it, really. This one, I mean, I guess that's helpful, but also maybe not that much. I mean, I believe it. The code should be pretty tight. Alright, so what am I missing? This part is too liberal. Is there any other case where we force a need? This is the one, so... Well, the need doesn't do anything. We don't... No, the need does something if at the end, but that's it. And all we need is a 1 after that, right? Let's put force less than 10 for a second, and then maybe we can debug the smaller number. Okay, let's debug 15, say. 7 and we have 9. What is 15 again? We can print this more. Decided to download this thing, which would be funny, actually. X is that many digits. Each digit could be popped in. No, this should be right. Math could be cleaner, but it should be right. Okay, so 15 we have 7, and I put 9. Why do I think it's 9? This is so annoying because I feel like I'm mostly done, but yeah, well, it is what it is. All right, index. What's it? Prefix, need, total. Expensive debugging. 1, 1, 1. Then why is it 9? Okay, so what is this returning? So it's counting. Okay. Maybe it's here actually. That'd be funny if that is true that I was here. I mean. Okay, so what is the 7 from? Oh, the first. I have no idea what this 7 is from. Oh no, it's this 7. But this is already 8, so we're definitely already wrong. That's fine though, right? Okay, 1. Oh, this is the number of binary bits. Oh, I'm doing size instead of size over 2. I am dumb. Okay, that's an easy fix. I think I'm maybe off by 1, but that's an easy fix anyway. Maybe. But that was definitely wrong though. Okay, I have to think about it for a sec. So if it's 3-digit, we want Z. If it's 3-digit, then 0. Then we want up to 2-digit of good things. 1-digit. Well, we want so then just 1-digit. So then it goes from 1 to 2. So it's 3 digits. Then now we're 2. I think this is right, or this other one was right, maybe. Okay. Well, I think the answer is 2. I am dumb. Okay, so the 4 digits. I'm dumb. I made the same mistake like in so many places. Okay, so it's 1, 2, 2, 4. The 2 seems is 2 wrong? 0 is just wrong. We don't want 0 anyway. So then it's just, but 2, 2, 4 is definitely wrong. Right? 2 is 2. We have 2 digits. Oh, I did it in a weird way. I want half the digit, so this is actually just, oh, that's why. Okay, maybe that was right actually. Though it's very awkward. So then now it's 4, so then it's 2, 4, 2, 2, 4, right? 1 digit is gonna have 2. 2 digits is 0, 0, 1, 1, 2. 3 digits is 4 is right, so this should already be 8. Why am I at 7? Well, why is the real answer 7? Am I like, this is the real answer, but Oh my. I have 41 minutes. I should be able to solve this, but I'm just being dumb today. Okay, so 1 digit. Oh, 2 digit is, oh, 0, 0. There's no leading zeros. There are no leading zeros. And also you can't just do 2, 2. Okay, so we assume the first, okay, okay, that's tractable, right? Okay, so then, okay, so that actually solves this part that I needed to do. Okay, so then now the first digit is a 1, right? So then now you have the first and the last digit is a 1. So then you have x minus 2, 3 digits. And then, yeah. If this is a 1, what happens? You have 1 digit. And then if there's 2 digits, then it's, oh, I guess it's just this plus 1, really. So I don't need this. Maybe, because having that as -2 is awkward, so maybe we still need it. What's the answer we're looking for? Oh, it's 7. Okay, I mean, so 0. Let's see. Okay, maybe now a of 0 matters. We have 7 just from these, and then I do one more, and that is where it comes from. How many digits are there? 4. So there are 4 digits. We have 1. True, true. What is S anyway? Oh, this is S. So true, but the need is not true. This should be, if this is 0. I don't know how I messed that one up. Okay. And then the answer is 9. Is the answer 9? No, the answer is 7, right? Because we have 1, 2, 3, 4, 5, 6, 7, right? But this is wrong then, because this is already 7. We have 0 digits, 1, 2 digit, 0, 1, 2 is still 2, right? Why is 2 2? Because it's 0. Power of 2 to the 0 is 1. Okay, 2 to the 0 is 1, I suppose. Maybe I don't need the plus 1. Maybe I just... Yeah, okay. I believe that. Alright. I got this one right. Let's try some bigger numbers. Okay, maybe without all the printing. This one's actually probably fine, but we'll still take it out. Okay, still a little bit wrong. Off by a couple. 7 is right, but everything's off by 2, which is maybe okay if it's consistent, but I don't think so. So, that's actually very sad and annoying. Okay, so we're at 15. Let's go back to debugging. Let's say 17. What is the next number after 15? Oh, I guess 17. Okay, let's try 100. I think 100 was the incorrect one anyway. We have 18, so we're undercounting. Why are we undercounting? We have half an hour. Man, I'm never solving any of these anymore. I'm just like so bad these days. Okay, so this is 100. 100 is 20 bits. What? Was that from a previous problem? Maybe that's from... No, that's... Oh no, 20 is the right answer. Okay. Okay, 20 is the right answer. This is S. So then now the prefix with 15 from 0 to 6. 0, 1, 2, 3, 4, 3, 4, 5, and then 6. Right? I don't know what that means. Alright, this probably tells me this is right. It's probably right, right? 15, okay. So then it is based on this. So, 6, this is 7. So 7 has 5. Well, up to 100 anyway. I guess it goes beyond that, but I only put 3. So it's definitely on the thing. Okay. ones. Maybe I'm not getting it. Maybe I thought I was getting it, but not getting it. That would be sad. Okay, so we are index 1. True, true. This is 3. Okay, 2. So it goes true, true, and 0. Okay, I guess that's true. Yeah, you can have any with this prefix. Okay, so I think this is correct. But then, okay, so 3. Okay, so 1, 2, 3 is false. If it's false, then it should be. Wait, this is true 2, which is true. Okay, that's fine. This being 1 is also fine, I think, because you need a 1 to balance it out, I suppose. Do you? No, if this is false, this should be, doesn't matter. If you are false, okay, yeah, maybe this is wrong. The prefix and need. Is that true? If it's anything you want, then no, by definition, if it's anything you want, then you have anything you want. Okay, I'm still missing one though. There's only 2 degrees of freedom. No, they're not more than 2 degrees of freedom. Well, this has to be a 0. Because if this is a 1, no, if this is a true, we can have 2 true is not giving me a true. Is this the right thing to go by? Maybe I'm missing one because it should. No, this is right. But this is wrong though. 3 true. Oh wait, no, because it's 1 0. This has to be a 0. Okay, so maybe that's right. But why am I missing one? Why am I? Number am I missing? Okay, so this is good. Oh, I'm missing this one for sure. Yeah, no, I'm missing this one. I don't mark it as right. So okay, so it's true. Then what? It just has to have a 1 before. I thought it has to have a 1 here, but this. Oh, how do I handle that? Because this 1 means that all these could be. Oh, so that means that. I see. So there's a need, but there's also last 1. I see. Okay, so okay. if there's a 1 in the opposite thing, then you need is okay. Let's see. Okay, so this is true, but if this is a 1, then we actually also set the false, which in this case will be false anyway, but in this case I might not, right? So basically in this case new need is equal to need, but if this is a 1, this is a 1, then we actually set it to false for anything, really. Well, this is, can never be happen, and then it's false in the other cases, right? Wait, I don't call it. Wait, did I make a mistake? I mean, I okay, yes, okay, come on, second chance. Yes, okay, but is it right for the other cases? Where's the reset test cases? 100, 15, 1,000, 1,000. I just want it real quick. There's too many print things. I don't know what the right answer is. I have to brute force code, so it will tell me. Okay, so 2762 is 205. All right, we could even try one more for good luck, because we counted to 1 million for some reason, I think. 1 million or 100,000, I don't even know. Okay. Yeah, I mean, we're almost done, so might as well. Oh, 2,000 to, that's actually kind of coincidental. Okay, let's remove this, and then let's remove the okay, that's also, yeah, I guess we could keep the print, but it's fine. Let's remove it anyway. And then let's make this 1,000. Why not? No big deal. All right, YOLO submit. Did I not? 200 is sad. 100 is right, but 200 is wrong. It's very annoying, actually. Did I not print? I just thought I could print. Oh, am I just dumb? I changed it to 1,000, but then my small is only a, okay. That is the dumbest mistake. I was like, why is this not printing? Okay, well, okay. I mean, at least, you know, that's a real wrong answer and not a dumb wrong answer. But that's actually sad, though. We have 26 minutes. We should still be able to figure this out. Hopefully, it's a long time. But yeah, but we're definitely off by 1. We're over by 1. What are we over by? Because 1,000 is right. Right? Trying to find which one am I overcounting. I guess 60 is 62, right? I was hoping to not mess with it, but I guess this one. 62 is right. Okay. 94 and 93 we overcount. What do we overcount by then? Oh, I this is because of if itself, maybe if it's not digit thing. If index is not equal to someone like this. Because I forgot that I have that case. Okay, that's it. Actually, 110 is somehow right, but we undercount and then overcount and overcount again, or overcount, undercount, overcount again. Okay, so that's on 200 or 2,000. Sorry. Let's binary search this. No, but I'm just trying to figure out like what is it overcounting on. 70. So we overcount at 1,500. What number are we overcounting on? Okay, let's see. So easy way to do this, the way that I did the caching. It's so annoying. Off by 1. This prefix is always happens if need. And then it clears everything out because if this is a 0, it clears everything out. This is a 1, and well, we're over counting, not under counting. This feels right, but am I missing a case? No, am I clearing something that shouldn't be cleared? I guess that's the question. If this is false, it doesn't change. If it is true, it only changes if that is true. Or if this current thing is a 1. Oh yeah, wait, but the current thing is a prefix is a 1, and this would just be false anyway. Is this still needed? Maybe that's why. Maybe I cleared it out correctly. Nope. Now I am still wrong. Man, this is frustrating. Alright, let's just binary search this. It's not binary search, but it's close enough. 22 minutes. Oh man. Even when I'm almost good, I am not good enough. 72, 75, 70, so 1500. So close. Maybe. Wow, we're even off by a bunch in some of these. So okay. Why is that? That's actually off by a lot. Like this should be continuous, for example, but like all of these are wrong in some weird way. Okay, so maybe we won't get it. Maybe we're just off by a bunch. This was not the first 2. Okay, so I'm really off by the time it's 1440. There's so many digits, I don't even know how to debug this, honestly. Am I like off by 1 on size or something weird? Why would it come up only when... I mean, this is 76, but then it gets smaller. What the... there's probably a way I could write a for loop about this, but alright, that's good. Also good. I guess I should have written it offline because I don't have a good setup here. But clearly this is wrong. So it's not the first 3. Let's just remove the first 2. What is special about this? Huh? This thing. we have 11 digits. So the middle digit being a 1, maybe? Maybe that's a thing? Because I don't know that I know how to handle the... Oops. What happened? Okay. I don't know that I know how to handle the middle thing being a 1. Because I kind of just... in this case, we're undercounting, and then in the future, we're overcounting. It's off by like 2, not even off by 1. How? It's this middle thing. Okay, so now we moved that. So it is definitely like the middle, weird middle digit thing. All right, so maybe we have to think about, let's just handle it, right? So if, okay, so then now let's think about all the cases. Maybe that's what we have to do. Okay, so then now within the middle digit, if not prefix, then it can be 0 or 1, right? And we just yeah. Let's just do it this way then. Do I need it? I guess it's true and false. This is, well, it's not always true, but it's just input technically speaking, but it doesn't change anything. Oh, well, maybe it did. I did change it. So if it's 0, then it doesn't change the need. Yep, okay, fine. If, and then this is a 1, so then now it's set false and false, right? Okay. Else, okay, else is a tricky part, but that's okay. So if it is the prefix, if s of index is equal to 0, then what happens? This is actually base case, I think. So if need, then this is, if not need, then we increment. I guess we should convert it to be a base case instead of some weird case. And then, okay. Okay, so given the prefix, we have s of index is equal to 0. Okay, then that means that this has to be 0. There's no way around, yeah, there's no way around it. And prefix is always true, so, oh yeah, we don't have to write this out. So that means that it has to be 0, so increment by 1. Else, if it's a 1, then it could be 0, okay? And then it could be a 1. If it is a 1, then need is becoming, oh wait, we have to care about need. If it's 0, then if not need, then we have to put a 0, right? Else, then we could put a 1, because it's a 1, and that's fine. So then, and then I think this is fine. Yeah, maybe. Nope. So maybe that's not, this isn't the situation then. Well, this isn't the case, but So that I'm just doing this wrong. If this is a 0, if it's not, we don't need it. I don't know how this could be though. If this is not prefix, no, this is wrong. Maybe I'm just getting this part wrong. Okay, maybe, because if it's not needed, I think this should be still not prefix. With prefix and this, then. All right. Well, let's try to. I can't believe like it passed all our random tests, but not actually all of them. Obviously, like we tested a lot of numbers, but and we just got lucky. 902. Okay, so we still have some wrong things. So that's a little bit sad for sure. Maybe I just don't know. Maybe I'm clearly missing like a little bit of my logic. I think this is needed though. No, prefix is probably right, or I don't know how to debug this. I mean, it's probably another thing where, you know, the middle bit, I overcount maybe. Alright, let's just see, try 0. If we try is just ever needed? Maybe that's it. But we're overcounting, so that also doesn't change the answer somehow. Well, change the answers to these, so maybe it isn't necessary. But that means that this is probably necessary for consistency. So I don't know, but then that means that the other things are wrong. Oh. Did I do anything else wrong? Maybe I won't get it. It is very frustrating because we're so close. And 11 minutes, I don't think I have time to reset. I feel like that's how I've been the last couple of contests, is that I've been so close, but I'm just a little bit off. Why is this we can't again? So try 1. Oh, we can't try 1. Okay, that's fair enough. Else we can. New prefix is true. Isn't new prefix always true? I guess so. Because, yeah, because it can only do if the prefix is a 1. If this is a 0, then, and we have a 1, then we need a 1 somewhere in the future. Is that true? Is that why I'm overcounting? Because the idea is that if we keep the prefix, this is still going on, right? So we have a 1, 0, but then you have 1, 1. I think that's maybe it, but how do I represent? How do I say that in a good way? Okay, I mean, I think this part is maybe right, but there is a thing where you just because you have a 1 here, you don't erase it because you don't take advantage of it. Because if this is a 1, then it's still true. Like the old one, rather. I mean, still not right. Now we're undercounting. Is this right? Honestly, I don't think so. But I am YOLOing because I have 8 minutes. Right? So why not? It matches, right? So why not? Why not? I think I don't even have to remove this. It doesn't really do anything, but I don't think this is right though, because we just kind of. I don't know how that's right. I'm just kind of happy. I mean, why is this? Like for symmetry reasons, I don't get why this is right. I did realize that this part I did mess that up, but and I was honestly 100% I was YOLOing because I mean what else I have got to lose, but I don't. It's very weird for sure. Like I don't. Like what? Why is it? Because if you have a, I mean maybe there's something with the. Oh, because this is a one. No, it's a prefix. Oh, this is because you can free to do anything. But if you're free to do anything, and you still need a 1, why would giving it 0 help? I honestly don't get it. Like I would not be surprised if I fail system tests or whatever. Like why? Like, does this matter? Because for whatever, like symmetry reasons, I feel like this doesn't make sense, right? I guess if this passed, then maybe it makes sense. I just kind of thought I needed it. Okay, no, this doesn't make sense then. I don't know why. I mean, it also might just be like I said, wrong and just pass all the test cases, but oh no, I'm just dumb. Because prefix I need, this is actually on this part. Okay, maybe I am just dumb actually. Yeah, okay. Actually, no. This is symmetric. Or the logic is consistent rather. And I wrote this in a really funky way. This case analysis. It's good that we sort this part out though. Do I need it? Maybe. It is way weird. Do I need it? I guess so, right? Because no, maybe not. Yeah, because I thought I needed it because I guess I missed this part, which is a little bit dumb. I didn't miss. This is a legit case that I missed. Because it is saying that if you have something like I don't know how to write it. Something like this, right? And if you do one, just because you do, okay, the first one is a whatever, and then now you have this one. If you do this one, it doesn't mean that you remove the requirement. Maybe you have, let's just say you have this is a 1, right? because you remove this 1 and then you put a 1 here, it doesn't remove the requirement that you need a 1 in the future. So you have something like this, 1, 1. This does not remove this requirement, right? Because you still need a 1 or like in between, because this 1 is symmetric to this 1. So that means that you need a 1 in between, but this one does not invalidate this one being anything, right? Because this one is still the prefix, and as a result, well, it's the prefix and the suffix, so that if you put a 1 here, the state doesn't change, right? Because if all these are zeros, and I guess that's all you have to say, is that if all these things are 0, this number is still bigger than this number. So you still need a 0 in between, and that's why, okay. So just missing this part. I guess I thought maybe it was the middle bit part, but I guess I actually handled it cleaner than I thought. But I just kind of missed one case, which is a tricky case that I was trying to articulate. Hey everybody, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Yeah, and everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.